For most of human history, the night sky was a place of wonder and uncertainty. People gazed at its shimmering lights with curiosity, yet only a few truly understood what they were looking at. Long before modern telescopes, space missions, or scientific observatories, knowledge about the heavens was limited to a small circle of highly skilled thinkers. What is often forgotten today is that some of the earliest contributors to this understanding were Muslim women, remarkable individuals whose intellect, craftsmanship, and dedication shaped the science of astronomy in ways that history did not properly record. Between the 8th and 14th centuries, the Muslim world became one of the greatest centers of knowledge in human civilization. Stretching from Spain to India, it flourished with libraries, universities, observatories, and scholarly institutions that attracted students from every region. Cities like Baghdad, Cairo, Damascus, Cordoba, and Fez became hubs of scientific progress. Scholars debated philosophy, physicians wrote medical encyclopedias, mathematicians crafted new theories, and astronomers mapped the sky with unprecedented precision. And in this thriving intellectual atmosphere, women were not merely silent observers. They studied, taught, collaborated, and in some cases made scientific breakthroughs that changed how humanity understood the universe. Before exploring the women who contributed to astronomy, it is essential to acknowledge the woman who laid the foundation for generations of scholars, Fatima al-Firhi. In the 9th century, she established the University of Al-Qarawiyyin in Fez, Morocco, recognized today as the world's oldest continuously operating university. Her institution became a center of learning, where mathematics, astronomy, theology, and philosophy were taught side by side. Students traveled great distances to study under its scholars. Fatima's legacy ensured that education was not restricted to gender or class, and her university created an environment where the pursuit of knowledge was open to all. Without this intellectual foundation, the scientific achievements of many later women might never have emerged. Among those extraordinary women, one name shines the brightest: Maryam al-Astrolabi, a 10th century Syrian astronomer and engineer. Maryam became renowned for her mastery of the astrolabe, one of the most sophisticated scientific instruments of her era. An astrolabe was essentially an early analog computer, capable of determining time, calculating latitude, tracking the positions of stars and planets, and helping travelers navigate long distances. It was used for everything from scientific observation to religious practices such as determining prayer times and the direction of Mecca. Maryam did not merely reproduce existing designs, she refined the instrument, improving its accuracy, craftsmanship, and functionality. Her work was so exceptional that contemporary historians praise her skill as superior to many male craftsmen of her time. Maryam's journey into the world of science reflects the intellectual environment of her society. In many parts of the medieval Muslim world, women were able to receive private education, attend scholarly gatherings, and study subjects such as mathematics and astronomy from within their own homes. Maryam learned from her father, who was also an astronomer, but her expertise came from years of dedication, mathematical calculation, and artisanal precision. She was not considered an exception or an anomaly. Instead, she represented a broader cultural openness toward women in scholarship. For her, knowledge was not viewed as a boundary, but as a calling. Astronomy held a special place in Islamic civilization. The need to track the lunar calendar, identify prayer times, determine seasons, and navigate vast trade routes made the study of the sky both practical and essential. This demand encouraged scientific growth and created opportunities for scholars regardless of gender. Many women became involved in copying scientific manuscripts, calculating astronomical tables, teaching younger students, and even producing or refining scientific instruments. Their contributions were quieter than those of famous male scholars, but they formed the backbone of scientific progress during the era. Centuries before Europe established its first observatories, the Muslim world had built advanced research centers dedicated to the study of the cosmos.
The House of Wisdom in Baghdad was one such institution, a place where astronomers, mathematicians, translators, and philosophers worked together. Scholars such as Al-Khwarizmi, Al-Battani, and Thabit ibn Qurra made groundbreaking discoveries here, developing the mathematical and astronomical ideas that would influence the world for centuries. Although the names of the women involved in these institutions are not always recorded, their presence is undeniable. They worked as scientific assistants, instrument makers, manuscript editors, and sometimes as accomplished scholars in their own right. Maryam al-Astronomy, though the most well-documented, was only one of many. So why did history forget these women? Wars, invasions, the destruction of libraries, and biased history writing all contributed to erasing their stories. Many manuscripts did not survive. In others, the contributions of women were overshadowed by the names of their fathers, brothers, or teachers. Later historians often focused solely on male scholars, leaving the achievements of women unrecognized. As a result, much of what we know comes from scattered references, brief notes, or preserved instruments bearing their craftsmanship. Yet despite this loss, the impact of these women remains profound. Their work shaped the tools that guided travelers across continents, influenced the calendars used for centuries, and contributed to the scientific foundations upon which later civilizations, including the modern world, were built. They lived in a time when curiosity was valued, when libraries stretched across cities, and when the sky was viewed not with fear, but with a passion for discovery. This is the rediscovered story of the Muslim women who studied the stars, crafted the instruments of astronomy, and illuminated the darkest parts of the night sky. Their achievements formed the first chapter of a history that deserves to be remembered, and this is only the beginning.
As the golden age of Islam matured, the thirst for scientific knowledge grew even stronger, and so did the contributions of women working quietly yet significantly inside scholarly circles. While Maryam al-Astronomy remains the most celebrated, she was not alone. Hidden behind the pages of fragmented manuscripts and brief historical mentions are women who calculated celestial movements, created instruments, corrected astronomical tables, and preserved the very knowledge that later generations would depend on. Their names may not echo loudly through history, but their work shaped the foundation upon which astronomy continued to evolve. One of the most fascinating yet lesser-known examples is the group of female scholars who lived during the height of the Abbasid Caliphate in Baghdad, a city often described as the scientific heart of the world. Baghdad's libraries overflowed with Greek, Persian, Indian, and Arab works that had been translated, commented on, and expanded upon. In this environment, women were frequently seen assisting scholars, sometimes as mathematicians, sometimes as instrument makers, sometimes as writers and editors. Many of the star charts and astronomical manuscripts that survived were copied by women whose handwriting was praised for its clarity and precision. Their roles were far more advanced than what later societies expected from women. They weren't merely scribes, they were preservers of knowledge. Among these women, a notable figure was Lubna of Cordoba, who lived in 10th century Muslim Spain. Cordoba at the time was one of the largest and most educated cities in the world, with libraries that held hundreds of thousands of books. Lubna served as a mathematician, secretary, and scientific scholar in the court of Caliph al-Hakam II. She worked on cataloging manuscripts, correcting astronomical texts, and solving complex mathematical problems. Contemporary writers described her as a woman of exceptional intelligence, fluent in science and literature, capable of solving equations that many trained mathematicians struggled with. While her primary reputation was in mathematics, her work in copying and refining astronomical manuscripts has preserved knowledge that might otherwise have disappeared. Another woman from Muslim Spain, Fatima of Cordoba, was also known for her contributions to astronomy and literature.
She mastered scientific writing and was trusted with editing advanced works, including astronomical treatises brought from the East. Her precision ensured that astronomical tables remained accurate when transferred from the old Greek system into the newer Arabic scientific tradition. Together, these women ensured that Cordoba remained one of the brightest intellectual centers in the West. Their work later influenced European scholars who drew heavily from Spain's scientific libraries during the Renaissance. Meanwhile, in the East, the scientific world was reaching new heights. Observatories were being built with instruments that had never been seen before. Giant sextants, massive astrolabes, and precise measuring tools crafted with incredible care. Women often worked as assistants in workshops that produced these devices. Crafting an astrolabe was not simple. It required an understanding of geometry, astronomy, metalwork, and artistic precision. Women were involved in engraving the star maps, calculating the angles, and checking the accuracy of the discs. Their steady hands and mathematical skill made them invaluable to the scientific community. In addition to craft work and copying, women played another essential role: teaching. Many girls in scholarly families were taught at home by their fathers or private tutors, and when these girls grew up, they passed their knowledge forward. Female scholars often taught younger students, both male and female, in private settings. Some became so renowned that their scholarly licenses, known as ijazas, were sought by prestigious students and scholars. Though most of these licenses relate to religious studies, several include references to mathematical and astronomical teachings. The scientific tradition in the Muslim world was not closed. It was shared, and women were active participants in preserving and expanding it. Their contributions were not always recorded by name, but their influence is present everywhere in the scientific manuscripts of the era. You can see it in the clear writing of astronomical tables, in the consistent diagrams of star positions, in the corrected calculations of lunar cycles, and in the refined instruments found in museums today. Their fingerprints remain on the very objects that helped sailors navigate oceans and guided scholars in understanding the cosmos. The respect these women enjoyed in their time becomes even clearer when studying the writings of male scholars who acknowledged their skill. Some describe them as masters of calculation, others as exceptional minds. Their work was not treated as unusual or improper. It was seen as a natural extension of their intellectual curiosity. The culture of the time valued scholarship so deeply that anyone with the ability to contribute was encouraged to do so. However, as centuries passed, political instability, invasions, and social changes caused many scientific institutions to decline. Libraries were destroyed, observatories fell silent, and manuscripts disappeared. With the fall of scientific centers came the slow fading of women's names from historical memory. Later societies, both East and West, began to restrict women's roles, and the stories of female scholars were forgotten. Manuscripts that once recorded their achievements were lost in wars or left unnamed by historians who chose to focus on male figures. Yet, despite being forgotten, their legacy survived through the knowledge they preserved. The astronomical instruments they improved, the manuscripts they copied, the calculations they corrected, and the ideas they kept alive eventually traveled across continents. These works sparked the rise of scientific thought in later civilizations. Modern astronomy owes a quiet but meaningful debt to the women whose names barely survived in the margins of history.
As the centuries unfolded, the work of these remarkable Muslim women began to echo far beyond the walls of Baghdad, Cordoba, Cairo, and Damascus. Their observations, records, and theories quietly shaped the foundations of astronomy in ways that would only be recognized generations later. Their names did not always appear in the grand chronicles of scientific history, but their fingerprints remained, traced across star charts, celestial models, and the very methods later astronomers would depend on. One of the most powerful legacies they left behind was the idea that knowledge was not restricted by gender. In a world where many societies placed heavy limits on women's education, the scientific environment of early Islamic civilizations offered a rare space where talent, curiosity, and discipline could rise above social boundaries. These women worked alongside fathers, brothers, husbands, and mentors, not to assist, but to contribute. Their ideas were part of the scholarly conversation. Their calculations were trusted. Their observations were preserved. Their influence continued through the generations of students they inspired. Manuscripts copied by their hands survived long after the original authors were gone. Star catalogs, updated by their careful measurements, kept scientific work accurate. Their translations of earlier Greek, Indian, and Persian texts protected ancient wisdom during a time when much of the world was losing it. And their corrections, small but crucial, helped refine astronomical models that later scientists in other parts of the world would rely on during their own breakthroughs. As centuries passed, the flow of knowledge carried the work of these astronomers across continents. European scholars who studied the heavens during the Renaissance leaned heavily on Arabic manuscripts, many of which had been shaped, copied, or corrected by women whose names were nearly erased from history. With every page turned, their legacy traveled farther. Their mathematical methods made calculations more precise. Their star names, still used today, guided explorers across oceans and helped map the world. Their approach to observing the night sky, organized, methodical, and deeply curious, became the standard for future generations of astronomers. Yet their legacy was not only scientific, it was cultural, intellectual, and deeply human. These women showed that passion for discovery could flourish anywhere, in private courtyards where telescopes were set at dusk, in libraries filled with manuscripts, in observatories that drew scholars from every corner of the Islamic world. They proved that knowledge was a shared inheritance, something to be protected, expanded, and passed forward. And they demonstrated what becomes possible when women are allowed to learn, question, and contribute without being silenced. Today, when people look at the night sky, they unknowingly trace the same constellations mapped by these forgotten pioneers. Every star chart, every celestial globe, every astronomical term with Arabic origins carries a whisper of their work. Their contributions were too precise, too brilliant, and too essential to fade completely. Even if the world forgot their names, the sky did not. Their stories remind us that human progress is never driven by a single culture or a single generation. It is built by countless minds, some famous, others hidden, working together across time. And among those minds were extraordinary women who studied the stars with devotion, discipline, and courage. They charted the heavens not just for their own era, but for everyone who would one day look up and wonder. Their legacy continues every night. Every time the sky is observed, every time a star is named, every time a question leads to discovery. The universe they once measured continues to expand, and so does the impact of the women who helped reveal it.